So far in Chapter 3, we've talked about constant rate of change and how to calculate constant rate of change when you're given a graph or a table. That was Lesson 1. What we're going to do, we're going to expand a little bit, and in Lesson 2, we're going to talk about slope. And I think that you're going to find that slope and constant rate of change are very similar. All right, let's start with your vocabulary start off. The term slope is used to describe the steepness of a straight line. Slope is a ratio of the rise, or what we call vertical change, to the run, or the horizontal change. Okay, so what slope does, it gives us a number value for steepness. Instead of saying, hey, that line is really steep, or that line is kind of flat, we can actually give it a numerical value. So when I say the slope of the line is 5, you're going to know that that line is very steep. Or if I say that line has a slope of 1/2, you know it's going to be a little flatter. Okay? So what I want you to do, I want you to go ahead and complete this graphic organizer. Okay? I want you to complete what you think the word slope means. How is this concept related to other math concepts? Where have you heard this in your life? And what makes this an important word for me to know? So go ahead and pause the video for a few minutes and complete this, and then we'll compare our answers. Okay, I think this word means, they put downward or slant. You could have put steepness. Okay, how is this concept related to other math concepts? Now you could have had different answers here, but it is a ratio. We looked up here at the definition. It's a ratio or it's a fraction. Rise over run. We have a numerator and we have a denominator, so it's a fraction, it's a ratio. Where have I heard this word in my life? Well, a lot of times it's used to describe a roof or a hill, or like if you're skiing on a ski slope. Okay? And what makes this an important word for me to know? So I can describe the steepness of a straight line. Again, it's going to give us a numerical value for the steepness of a line. Okay, and so now instead of just using it's really steep or not as steep, we have an actual numerical value. So let's see how we can calculate that number. Okay, again, slope is a rate of change, and that's what we talked about in Lesson 1. Okay, your rate of change, it can be positive, or we've learned that it can be negative. Okay, so I'm sure this is familiar to you. Slope equals rise over run. Your rise is the vertical change, and your run is the horizontal change. Again, vertical goes up and down. Run is horizontal. Okay? Okay, let's look at example 1. It says, find the slope of the treadmill. All right, so we start with rise over run. Our rise right here, you can see, is 10 inches. So 10 goes on top. Our run, which is our horizontal change, is 48. So we just make a fraction out of it, 10 over 48. And then, of course, we have to reduce. So our slope is 5/24. Okay? All right, so why don't you take a minute now, use that example, and why don't you try to do your got it problem. A hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope of the hiking trail? Go ahead and pause the video and try this problem. Make sure you reduce your fraction if it can be reduced. Okay, anytime you're calculating slope, I always want you to start off with a formula, and you're going to learn a couple different formulas you're going to see today, so you have to pick one. This one, the easiest one to do is rise over run, so we're going to start with that. Okay, so that we know the rise is always on top. Well, it tells you right here the trail rises 6 feet, and the horizontal change is 100. So your rise is 6, your run is 100. Okay, then you have to reduce your fraction, and it reduces to 3/50. So your slope for this trail is 3/50. Okay, now what if they give you an actual line on a coordinates plane? Okay, what you can do is make a triangle. Okay, so if you have 2 points right here, do you see how they've made this right triangle here? They're going to go up and over until the 2 lines meet. You can do it on the bottom side too. It doesn't matter. It's going to be the same. So this is actually a visual picture of your rise and your run. This 2 right here is your run, so that's why they put, or is the rise, that's why they put the 2 there. Your 1 is the run. Okay, so rise over run, 2 over 1, or your slope is 2. Okay, now what you need to do is you need to take a look then. If you do triangles, you have to be careful. You need to take a look at your line. See how if you're coming from left to right, it's going uphill? That is a positive slope. Okay? If it was coming down, for example, if your line was coming down this way, that would be a negative slope because you're left to right, you're coming and you hit this hill and you're sliding downward. That is a negative slope. And we'll talk more about that here in a little bit. Okay? All right, now sometimes they're going to give you a graph. Again, last lesson with constant rate of change, they gave us a graph, and here they gave you a table. Same thing, okay? We're going to use a formula that's very similar or familiar to what we learned in last lesson. Okay, do you remember this? Change in y over your change in x. Okay, look right here. Remember I told you didn't have to write the word change and you could use the triangle, the delta symbol for change? We're going to do the same thing here, okay? All we have to do is pick two points. We know it's linear, okay? They tell us it's a line. So we don't have to worry about finding the constant rate of change to see if it's linear. We already know that it is. So all you have to do is pick 2 points and compare them. So they chose 3. These are the points they chose right here. They chose these last two. So they picked their 2 y values, and they went 3 minus 6, and then they went 7 minus 5 for your x values. Okay? 3 minus 6 is negative 3. 7 minus 5 is 2. So your slope right here is a negative 3/2. So you could have picked 9 and 12 and 3 and 1, and you would have gotten the same answer, negative 3/2. It doesn't matter what point you pick because all these points are on that line. And that line has a constant rate of change because it's linear. Okay? So what I want you to do, go ahead and pause the video right now and try these 2 problems. Maybe use rise over run here, and then in this one, change in y over change in x. Okay? All right, so if you chose to do the rise over run, okay, let's start with that formula. Oops, this way. All right, so our rise, let's count. 1, 2, 3. So you should have a 3 for your rise. Your run, 1, 2, 3, 4. So your run should be 4, which gives you a slope of 3/4. And it is positive because it's going uphill. And that's all you have to do to find the slope of a line. It's probably the easiest way to do it if you have a line graphed on a coordinate plane. Okay, you do your triangle. Now this one right here, okay, I would use change in y over change in x. And you can pick any 2 points that you want to on this in this table to do. Okay, here are the points I chose. I chose to do these 2 right here. Okay, so what I did, I compared these and I went 6 minus 2, and that's actually my x value, so it goes on the bottom, and then my 1 minus 0, okay, and those are my change in y, so that goes on top. And 1 minus 0 is 1, 6 minus 2 is 4, and if you take a look, if you did the mountains, as we like to call it, 6 minus 2 is 4, 1 minus 0 is 1. So that's your rise, this is your run. So it's a lot of the same things that we covered in chapter 1. Alright, this is a video called Slope Dude. We're going to go ahead and watch this in class because this is going to help us determine whether a line is positive, negative, or there are actually 2 other types of slopes. So we will watch Slope Dude in class together so that we can have a discussion about it. There's one more skill that we want to learn in this section, and it's called the slope formula. And we've actually have already done it. It's your constant rate of change. It's your change in y over your change in x. But this time, what we can do is if they just give us 2 points, we can very easily calculate the slope. Okay? Here's how you do it. They're going to give you 2 points right here. R is 1 and 2. S is negative 4 and 3. So what you have to do, since this is your first point, we'll make this x1 and y1. Remember, our coordinates are x's and y's. This is our second point, so we'll make this x2, and this will be y2. Now, these 2's do not mean that you square it. It's a subscript. It's below. It's just saying that, hey, this is our second point. Okay? Notice how they're not up here. So, your slope formula, you're going to take y2 minus y1, which is the exact same thing as your change in y. So what you do here, take your y2 and your y1, so 3 and 2, and we're going to subtract them. Then you have your x2 and your x1. So your x2 is negative 4, your x1 is 1. So 3 minus 2 is 1, negative 4 minus 1 is a negative 5, so your slope is a negative 1/5. It is the exact same thing as change in y over change in x. We're just writing it differently. Okay? Same exact thing. We just plug in the numbers. Alright, so why don't you go ahead and pause the video, and then we'll take a look and see how you did. Okay, so when you start off finding the slope, I want you to start with a formula. Yes, I want you to write it every single time. Okay? Now, if you don't want to do this, you don't have to. If you don't want to label your points, don't. It'll help you. Okay, so here's x1 and y1, because that's our first point. We can make this x2, and this can be y2, because this is our second point. If you have them labeled up here, it's very easy to plug them in down here. Okay, so our y2 and y1, 3 minus 2, over our x's, 5 minus 2, which gives us a slope of positive 1/3. It's as easy as that. Again, it's the same thing, change in y over change in x. Letter E, here's our formula. Yes, you have to write it every single time. Okay, here's our y2. Here's our y1. Now, since our formula has a minus in there, why do I have a plus? Well, let's take a look at our numbers. Negative 2 minus a negative 4. Oh, minus a negative 4 is the same thing as plus 4. Again, I don't normally like to write two signs back to back like that, so I'm going to change that to a plus. Okay, but it still means the same thing as minus a negative 4. Our x's, negative 3 minus a negative 7, is negative 3 plus 7. Simplify, and you get 2/4, which reduces to 1/2. Okay, make sure you reduce your fractions. And that is basically it for slope. That's the basics of slope. So what I want you to do now, go ahead and try the guided practice problems. And when you come into tomorrow morning, we will go ahead and take a look at those and see how you did.